In this video, I will talk about the building, analysis, and the revision of the rockets that my group built. It would only be fair to start from the beginning. Our first step was to make an initial rocket design to test our prior knowledge. After we made that blueprint, our next step was to research on how/why the rocket launches in the best shape for all of the rocket parts to be. From there, we made several other blueprint designs, some having problems like being too complex or having bad ratios from one part to another. Finally, we came up with a basic design that would also be effective. The next class we had the paper rocket test to do, so we translated our design into an even more basic format so that it would work for something as small as the paper rocket. That ended up with the cone being just a paper twisted and then tape over it to increase the aerodynamics. Then the wings were triangles with a lip so we could tape it to the actual rocket without having to bend the wing. Our first build ended up going about 320 centimeters. Looking at the launch, it was very clear it was too top-heavy as it plummeted straight down very quickly. To fix that, we added layers of tape to the sides of the rocket, lowering its center of mass. It was clear that we did proved effective, as the next launch ended up going 512 centimeters. After the paper rocket, it was time for the first launch. We put together our original blueprint with what we learned from the paper rocket experiment. That left us with a rocket that has triangular wings, a cone, and a tennis ball, which was 54 grams to act as the top weight, providing a near ideal center of mass. From there, we filled it up with water until it was a total of 960 grams. At this point, we were ready to launch for the first time. That launch went quite well for the first attempt, reaching about 22 meters. Seeing that, we were pretty happy, but we decided we could try again. Just like with the paper rocket, we wanted to try and lower the center of mass. A big difference was this time we instead chose to lower the top's mass rather than add mass to the center. So we used the same rocket, the only difference was that instead of the 54-gram tennis ball, we had a 34-gram aluminum ball as the top weight. From there, we filled the rocket up with water until it reached 986 grams and then launched. We quickly noticed that rocket was less successful than the original rocket, only getting up to 18 meters. Confused, we decided to sit and analyze this for a bit, as well as doing more research. From that research, we learned exactly how important the center of mass being more towards the top is to the rocket. Then when looking back, we saw the lower mass could only take 7 pumps before launching, while on the other hand, the heavier mass could withstand 10 pumps. And we were still able to pull the string. So that analysis led us to the conclusion that with more mass on the top, it could withstand more pressure from the air molecules, allowing for the thrust force after launch to be stronger. With that idea in mind, we knew that we had to increase the mass of the top weight. What we ended up doing is taking the tennis ball and wrapping it in duct tape, bringing it up to 63 grams. From there, we filled up the tank with water, reaching 989 grams. Then we began to launch it, this time being able to get 12 pumps in, as well as being able to pull the string. What the? Let's go! Let's go! What? That rocket went far higher than the other, reaching nearly 31 meters. Our idea from there was to continue adding mass to the top. That led us having a tennis ball wrapped in duct tape as well as packaging tape. It ended up weighing a total of 74 grams. This time, however, instead of a printer paper cone, we used a construction paper cone. We filled the rocket up with water until it reached 980 grams, and then launched again. That launch was far worse than the last one, only going up about 19 meters. But regardless, we decided to launch again with the same design, except this time using a printer paper cone. Once that was finished, we filled it up with water until it was also 980 grams. Unfortunately, it proved to be just as bad as the other, reaching 19 meters as well. In the end of it, our highest rocket was the one with a top mass of 63 grams that reached about 31 meters.